Okay, so where we left off last class was we did derivatives the long way. And then at the end of class, we're like, hey, there's this really cool shortcut way. Because of the long way, we can do it the shortcut. So I've given you this really, really long problem, and I'm asking you to find the derivative. Now, the reason why I gave you this really, really long problem is if you practice this enough, you will come to the conclusion of it's the same thing. I don't care if it's a number. I don't care if it's a fraction. I don't care if it's a decimal. I don't care what it is. The process is still the same, right? So the first step that I would always do is if there's any chance to rewrite it to make it easier, I would. So notice that when I rewrite this, I'm not going to put f prime. It's just f of x, just rewriting it. The first one is good to go. The second one is good. The third one is good, even though it's fractions. The fourth one's good, even though it's decimals. The fifth one, fraction and decimals. Oh man, what are we doing to us? But the other ones can probably be rewritten a little bit. So for example, -3 square root of x. Instead of square root of x, what can I call it? X to the 1/2. The next one is okay. But here, see the x to the 7 is in the denominator. When I move it up, it's going to be x to the -7. And then this one, we have 6 over the square root of x. Well, we just said that the square root of x is x to the 1/2. When I move it up, it's going to be x to the -1/2. And then the last two are okay. So notice that I rewrite it first. Then I'm going to take the derivatives. So what you're going to learn today as we do a few more weird ones is that rewriting it will help you. In order to rewrite it, you need to know your algebra, your math skills in order to rewrite it first. So notice as I go through this, it's getting a little harder each time. Try to catch yourself. This is an individual thing. Where am I making mistakes? Is it the fractions? Is it the decimals? Is it the calculator? Is it I don't know how to rewrite it? Is it I don't know how to do the shortcut? It's all personal at this point, right? But we're all going to get to the same level as long as we practice. So the first one, again, what's the shortcut? Exponent goes to the front, subtract 1. So this is going to be 10x to the 9. And you're like, I got that. They're all the same. Every single one that I'm about to do, the entire problem is the same. Exponent goes to the front, subtract 1. Why does it work? Because we did it the long way. The long way is the proof that it works. So the next one is going to be -21x to the 6. Then we have a fraction. It's just a fraction. This is going to be 2 over 6. Which is 1/3. And you're like, oh my gosh, I'm not that good at fractions. Number one, you got to be good at fractions. And again, you have a calculator. If I do parenthesis 1/2 in parentheses 2/3, enter math, number 1 for fraction, you get 1/3. Okay, but we should know fractions. We shouldn't be worried. Same thing with when we work out the next part. Just like 10 minus 1 is 9, 7 minus 1 is 6, 2/3 minus 1 is what? -1/3. And if you're like, how did he get that? Again, you need to know your fractions. If you do parenthesis 2/3, close parenthesis, -1, you get -0.333333, math, fraction, you get -1/3. So your problem has nothing to do with calculus. It may be fractions, or maybe it's not, okay? Minus, you may not know what 0.4 times 0.9 is. It's 0.36, but again, you can use your calculator. 0.4 times 0.9 gives you 0.36. There's no excuse, no worries. We should be good with fractions and decimals. And again, if you subtract 1, you get -0.1. Again, if you need to use your calculator, 0.9 minus 1 is -0.1. Okay, so I'm trying to show you all this because I'm not going to do it all the time, but you have your calculator, so we have a backup. We shouldn't have any reason why we're worried about any of these. And 1/4 times 0.2, okay? Parenthesis, 1/4, close parenthesis, times 0.2 enter. That gives you 0.05, which you can leave it as a decimal, or math, number 1 for fraction, 1/20. Either one's fine, either one's fine, either one's fine. I'm going to put 1/20 x to the, and then 0.2 minus 1 is negative 0.8. Again, if you need your calculator, 0.2 minus 1 gives you negative 0.8. Okay, and now that this is all rewritten, this is going to be minus 3/2 x to the negative 1/2 plus 16 x to the negative 3 plus 28 x to the negative 8 minus 3 x to the negative, what is that going to be? What is it going to be? Negative 3/2. Okay, again, if you're having problems with fractions and decimals, use the calculator, but hopefully we don't. Okay, now the last one, what's the derivative, the last two, what's the derivative of negative 10x? Negative 10. Remember why? There's a 1 here. 1 times 10 is 10, and 1 minus 1 is 0, no more x. And what's the derivative of minus 3? 0. What's the derivative of any number? 0. Okay, now that is a final answer, but as I mentioned before, I want you to get in the habit, just like you're able to rewrite it, anytime you have a final answer, I would write it with positive exponents. So here we have a negative 1/3, it goes to the bottom. Here we have a negative 0.1, we move it to the bottom, becomes positive 0.1. This is just exercise, practice, going from negative to positive exponents. But if you got all of these correct, fantastic. If you got any of these wrong, it's okay. Find out what happened, why did you get it wrong? Was it a fraction issue? Was it a decimal issue? Was it a calculator issue? What part of it maybe gave you the wrong answer? So we're going to go back to the chapter 2 notes. And to be honest, we're kind of getting a little bit further than what the notes are doing. We're doing a little bit harder. So I'm going to skip these problems for now. I think we've kind of gone through these. If you want to try 2 of them, let's, for quick practice, let's try these 2 here. Let's try C and D. This is going to give us a little help rewriting. So the first one I want you to try, what if you had, I'm just going to rewrite it with an x, 1/3 x to the 3rd, find the derivative. What if you had 0.9 over cube root of x? So I'm trying to just pick the weirder ones just for you to practice. Give those 2 a try, give those 2 a try. And again, we're trying to figure out what is it that's giving us a little bit of issue. What is it that's giving us some issues? Is it the rewriting it? Is it knowing what to rewrite or what it is? Try to figure out what it is. Try to figure out what it is. Find the derivative of both of them. So for both of these, I'm going to rewrite it first. And again, this is where we get a little trouble, right? Being able to rewrite it. So this is going to be still the original, 1/3 x to the 3 goes up, x to the negative 3. So I just rewrote it. Didn't take the derivative, just rewrote it. The second one, if you rewrite it, this is the cube root. So this is 0.9 over x to the 1/3, right? There's a 1 here, 3 there, that's 1/3. When it moves up, it's x to the negative 1/3. So number one, do we know how to rewrite it? Do we know how to rewrite it? If you can't rewrite it, we're not able to take the derivative. And that's a exponent, that's an algebra, that's a math thing that we need to know. Then negative 0.3 times the 3rd is negative 1, x to the negative 4. So I would put your final answer as negative 1 over x to the 4. That would be your final answer for that one. And again, if you don't know that 1/3 times negative 3 is negative 1, I'm not going to do it all the time, but you have a calculator. Negative 3, parenthesis, 1/3, close parenthesis, enter, is negative 1. Okay? And then negative 3 minus 1 is negative 4. We should be comfortable with that. Negative 3 minus 1 is negative 4. Okay, so again, I'm not going to show the calculator all the time, but you do have it. Same thing for the next one. Negative 1/3 times 0.9. You can use your calculator. 0.9 parenthesis negative 1/3 gives you negative 0.3. So that's negative 0.3. And then negative 1/3 minus 1 is negative 4/3. But again, if you need your calculator, parenthesis negative 1/3 minus 1. And then we get math, fraction, negative 4/3. And if you're like, oh, these are so much harder, they're the same. The reason why you think it's harder is because it's a fraction and a decimal, but they're the same. Exponent goes to the front, subtract 1. Exponent goes to the front, subtract 1. This would be negative 0.3, and I would move that negative 4/3 to the bottom, and it becomes positive 4/3. Okay, but that little time where I gave you to try on your own, that's what you're figuring out. Do I know it or not? Afterwards, you're like, oh, yeah. But during, can you do it? Can you do it? Can you do it? Okay. A couple more, kind of what we've already covered, but I'll give you a couple more practice. Let's try C and D here. Okay, so this one is just using a different letter, so we'll kind of stick with the different letter. This is y equals 5v to the third minus 4th root of v. And then the second one is going back to x. So this would be negative 3/4 over x plus 4 over x to the third minus x to the 4 over 8. Okay, so again, rewrite first, and then take the derivative. Okay, so again, anytime it's got something a little weird to it, we should rewrite it first. So this is just y, rewriting it. 5v cubed minus, this is a v1, that's 4th root, so that's v to the 1/4. Just getting comfortable rewriting it first. Then when I take the derivative, we do y prime. So that's going to be 15v squared minus 1/4 v to the, what is this going to be? Negative 3/4. Again, if you need the calculator, use the calculator. If you're like, I'm bad at fractions, use the calculator, okay? I'm not going to show it every time. And then I would rewrite this as 15v squared minus 1/4 v to the 3/4 as my final answer. Okay, there's the first one. The second one, same idea, rewrite it first. This will be negative 3/4. This is x to the 1. When I move it up, it's going to be x to the negative 1 plus 4. This is x to the 3. When I move it up, it's going to be x to the negative 3. Be careful with the last one. There's a 1 here. So this is minus 1/8 x to the 4. It's already up, so we don't need to rewrite it. So rewrite it first, then take the derivative. This is going to be 3/4 x to the negative 2 minus 12x to the negative 4 minus 1/2 x to the third. And then your final answer would be 3/4 x squared to move to the bottom minus 12 over x to the 4 minus 1/2 x to the third. Now again, as you're looking at each one, what happened? Exponent went to the front, subtract 1. Exponent times the front, subtract 1. Exponent times the front. You're like 4 of 1/8. Use the calculator. It becomes 1/2. 4 minus 1 is 3. Okay, so double check it. But again, are the mistakes fractions, decimals, or is it the derivative? What issues do we have? Last practice one I want to do is this one right here. Okay, so we're going to go ahead and I'm going to ask you to find the derivative of this. I have explained enough where you are able to do this one. So I want you to find the derivative of 3 minus x to the third over x to the 6. Okay, find the derivative of that. So first of all, we said, okay, if it's an easy one, exponent times the front, subtract 1. Got it. And then we said, okay, if it looks weird, you should rewrite it first. Well, this one looks weird. But the question is, how am I going to rewrite it? We haven't done division yet. Some of you that may have done anything with calculus, remember quotient rule, we're going to learn that later, but we don't know it right now. So the question is, can I rewrite this so we can take the derivative? Yes or no? Can we rewrite it? How? You could move x to the 6 to the top and then distribute. That is definitely, that works. That's a good way too. What I'm going to do is a little bit longer, but what's being divided by x to the 6? The first, the second, or both? Both. So this can be rewritten as 3 over x to the 6 minus x to the third over x to the 6. So see how it was divided? We can rewrite this so it's not one piece, but two pieces. And then we're still rewriting. This becomes 3x to the negative 6. This becomes 1 over x to the third, so you need to know your exponents, which eventually still simplifies to 3x to the negative 6 minus x to the negative 3. Then you can take the derivative. So I'm going to pause there. Again, algebra, algebra, algebra. So when I take the derivative of this is going to be negative 18x to the negative 7 plus 3x to the negative 4 to get the final answer of negative 18 over x to the 7 plus 3 over x to the 4, final simplified answer. Okay, now at this point, you've seen derivatives all different ways. I'm just exposing you to what if you have to rewrite it, what if you don't, what if you have a negative, what if you have a fraction, what if you have a decimal. You've seen it all now, right? There's still more to learn later on for more techniques, but as far as this stuff, you've kind of seen it all. So the next step, the end of this section and the beginning of the next section is going to all be about word problems. It's going to all be about word problems. So to finish up chapter 2, it's going to be about word problems. This one's kind of like a quickie word problem, just to kind of get started talking about word problems and what this means. This one says an object moves along the y-axis marked in feet so that its position x seconds is f of x, x cubed minus 6x squared minus 9x. So let's just stop for a second. And I want you, every single word problem, to label what is the x, the input, and label what is the y, the output. So don't say it out loud, don't say it out loud, but every word problem, if you don't know the input and you don't know the output, you're not able to do the word problem. You're not able to do the word problem. So take a minute, label what is your input x, what is your output y. The biggest problem we have with word problems is we don't read it. We don't understand it. If you don't know the input and the output, there's no chance. Okay? So, excuse me, after looking at that, what's the input? Time in seconds. And what's the output? Distance in feet. Okay? So before we do anything, what's going on? We have this object moving left to right, basically. And with the original formula, which is given here, you are able to find out what happens after 2 seconds and what happens after 5 seconds. So what I'd like you to do, using your calculator, find out what happens after 2 seconds, write it in a sentence. What happens after 5 seconds, write it in a sentence. Yes, a sentence. I'm going to use the calculator to do it. Obviously, you can do the work. You can plug 2 in for x and find the answer by doing the work. I can plug 5 in for x. I could always do it by hand. But again, we're using the calculator to save a little time. So I'm going to go to my calculator. I'm going to go to the calculator. go to y equals. I'm going to double check that there's nothing in y1, nothing in y2. Notice I have these two plots that are highlighted. I'm going to go up to it, hit enter, up to it, hit enter. And then in y1, I'm going to put the equation x raised to the third minus 6x minus 6x squared plus 9x. Then we've used the table feature before. One last check if you're using a different calculator. If you hit second window, ask auto, again, make sure it's ask auto, not auto. Then when you go to the table feature, second graph, you can plug in 2, and you should get 2. And you plug in 5, and you should get 20. Okay, so you get 2 and you get 20, but that doesn't mean you understand anything. So that's where the sentence comes in. At 2 seconds, the object, what? Yeah, is 2 feet away or has traveled 2 feet, however you want to talk about it. Then at 5 seconds, the object is 20 feet away. And again, if you left it blank, waiting for me to write it so you can copy it, that's a red flag. That's a red flag. Now, what I want you to do is graph this thing. I want to see a graph of the original. And if you haven't figured out by now, you're not going to get a graph unless you figure out the window. You now have enough information numbers to figure out the window. I want a graph of the original, graph of the original, graph of the original. So in order to graph this thing, we need to know what's the input. The input is time in seconds. And the lowest is going to be 0 seconds. I've asked you for 2 and 5. So I need to see 2 and 5. How far should I go? Maybe 10. Perfect. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds. Why did I randomly choose 10 seconds? Because I needed to see 2 and 5. So 10 seconds gets me there. Okay. Then my output is distance in feet. Well, the lowest is going to be 0. Looking at my outputs, what did I get? I got 2 feet and I got 20 feet. So that gives me an idea, how tall do I need to go? At least 20, so maybe go to 30. Perfect. So maybe we'll count by 5s. Maybe we'll count by 10s. But again, we're not sitting there waiting to copy what the teacher does. We're understanding input, output. We've gone through in chapter 1, word problems, calculator, algebra, right? We've done all this stuff before. This is why, right? So now when I go to my calculator, I'm going to go to window. I'm going to go from 0 to 10 seconds, counting by 1s. My Y, I'm going to go from 0 to 30, counting by 5s. And this is all original. This is no calculus. This is all basic algebra stuff, graphing stuff that we did in chapter 1 and you've done before. Then I'm going to hit graph. And you see that this object is traveling up, down, and then shoots up forever. Up, down, and then shoots up forever. And 1, 2, 3 is when it goes to the bottom. So it looks something like this. Okay. Now, when I looked at 2 seconds and I looked at 5 seconds, which is probably a little bit higher. 5 is about here. What did I find? I found locations. So if you go to your calculator and hit second trace, number 1 for value, number 1 for value, number 1 for value, type in 2, enter, that's the location. At 2 seconds, it's 2 feet off the ground. This is the distance from the ground. This is the distance from the ground. Then when I type in 5, enter, now where's that object? It's 20 feet above the ground. 20 feet above the ground. So this actually gives us more information that it's distance from the ground. Distance from the ground. Are we okay? So the ball kind of, if it's a ball, let's say it bounced and then it just shot way up. Good so far? Now you're like, this is all review. You're totally right. Now what we're going to do is I would like you to take the derivative of that function, find the derivative, and then I want you to plug in 2 to that derivative, explain that in a sentence, plug in 5 to that derivative, and put that in a sentence, because now we're doing derivatives. We're not plugging into the original. Now we're doing derivatives. So I want to know what the heck a derivative is telling me about that object. So if I take the derivative of the original, you're going to get 3x squared minus 12x plus 9. So let's make sure we got the derivative correctly. But the question is, what the heck is a derivative? What is it telling me? We know the original, you plug in seconds, and it tells you how many feet away the object is. But what is this telling me? What is this telling me? Well, if you plug 2 into the derivative, and if you plug 5 into the derivative, and again, I'll use the table, but just to show you, we could totally do it all by hand. Okay, I'm going to go to the calculator. I'm going to go to y equals. I'm going to leave y1 alone. So don't mess with y1. Don't mess with the y1. If you got rid of it, put it back. Leave y1 alone. But in y2, let's put the derivative. 3x squared minus 12x plus 9. Okay, so leave y1 alone, leave the original alone. And in y2, we put the derivative. So when I go to the table, y1 is going to tell me how many feet away that object is. And then we'll figure out what y2 tells me. So I go to the table feature. The derivative is -3 for 2. And the derivative is 24 for 5. So we have -3 and 24. What the heck is that? So I'm going to write it, see if we came close to it or came up with any ideas. At 2 seconds. So we're basically freezing time, and we're looking at this object moving, and we're freezing it at 2 seconds. The object is traveling. What do you think the negative means? Backwards, maybe. Yeah. Downward. So let's go back and look at the graph. If I look at the graph, now it's showing both. But if I go back to second, trace, number 1 for value, which is 2, notice on the blue one, see how the object is going downward. So the negative does have a meaning. It's going downward, 3 what? Feet per second. So this is not telling me how far away the object is. This is telling me how velocity, how fast it's moving, the rate of change. It's traveling downward at 3 feet per second, which is not that fast, right? Because at 5 seconds, the object is traveling. Now it's positive, so what does that mean? Upward, what? 24 feet per second. So this thing's speeding up from 3 feet per second and is now going 24 feet per second. So what is a derivative? It's a rate of change. It's a velocity. And derivative is not an average rate of change. It's an instantaneous rate of change. What's happening right now? What's happening right now? And if you're kind of talking about, wait a minute, average rate of change, instantaneous rate of change, what's the difference? Raise your hand if you have an E-Pass, Sun Pass, something like that. Raise your hand if you have one. Almost all of you have one. I have one as well. All of you can get a ticket all the time. And you're like, what? Yeah, that little device in your car tells you where you are at all times. So if anybody lives in Kissimmee, if you enter Osceola Parkway, get onto the turnpike, and you exit I-4, and you do that in 10 minutes, guess what? You're speeding. I know where you started. I know where you ended. I don't know how fast you were going every second, but average rate of change, where you start, where you end. Remember all those formulas we did? They can give you a ticket. And you're like, can they? Yeah, they can. Do they? No. Why? Because you'd go to court, you'd argue it, you don't know where I was, you didn't stop me, blah, 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 blah. But totally you can. Where you start, where you end, how long it took you, that's average rate of change. If you've ever gotten a ticket, how did you get a speeding ticket? A police officer shot the gun at you, the little speed gun, hopefully not a regular one, and they found your instantaneous rate of change, not Osceola Parkway to I-4, right now. That's what this is. This is instantaneous rate of change. Instantaneous rate of change. That's what we're finding with derivatives. We just did everything by hand. We showed our work and all that. Do you think your calculator can do all of this? Yes, it can. And I'm going to show you how. Okay? So this is a nice way to check your work, I want you to go to y equals. To be clear, y1 is the original. Everybody with me? y2 is the derivative. How do I know if that derivative is correct? What if I made a mistake? What if I made an algebra mistake? Well, go to y3. Go to y3. And when you go to y3, we're going to make that the derivative in the calculator. How do you do that? Press math, and go to number 8. Number 8, which says what? Derivative. So choose number 8. Now, this is where our calculators are going to be a little different. If your calculator looks like mine, follow along. If yours says n derivative, just kind of hold off a minute. The first blank, d over d, wants an x. So put x. And then it's asking, what do you want to take the derivative of? I want to take the derivative of the original. Where is the original? y1. The original is in y1. I want the derivative of y1, not the derivative of the derivative. That's something we'll do later. So where is y1 in your calculator? Press vars. To the right for y vars. To the right for y vars. Number 1 for function, and you can refer to anything on there, but where's our original? y1. Then push to the right, and at the end, they want another x. The reason why they want another x is we're taking the derivative with respect to x in terms of x. X. That's why it's 2 x's. Now, if your calculator looks a little different, no worries. If your calculator says n derivative and is waiting, it's waiting for the same thing. It wants y1 first, comma, x, close parenthesis. It's the same thing. 2 x's and a y1 is just a different order. So if yours says n derivative and is waiting, it's waiting for y1, x. But however you do it, let's check it. When you go to the table, which ones should match? y2 and y3. So when I go to the table, y2 and y3 should match. On a test, on a quiz, on a homework. If they don't match, something's wrong. Either you typed it in wrong, or maybe you did the derivative wrong. But this is a nice way to check your work. Are we okay? So, having said that, we're going to do, now we have everything set up to actually do some word problems. There's one weird one I want to do and not spend much time on, but your textbook and your homework sometimes refers to an object moves along this, so the position is this. Find the time when the velocity is 0. Velocity is what? The instantaneous, the derivative. So when it says, when is the velocity 0, we first have to find velocity. So how do I find velocity? Take the derivative, 3x squared minus 12x plus 9. And I want to know when the velocity equals what? 0. Do the algebra, solve it, which means you need to know how to factor. So if I was going to factor this, I would factor out the 3 first, which gives you 3x squared minus 4x plus 3, set it equal to 0. And then this factors to x minus 3, x minus 1. Set each piece equal to 0. And you get x equals 3. And x equals 1. Now again, x is seconds. So the velocity will be 0 at 1 second and 3 seconds. The velocity will be 0 at 1 second and 3 seconds. In order to solve this problem, you need to know that velocity is derivative. You have to set that velocity equal to 0, which most of you, that's not the problem, but the factoring may be the problem. And again, we're in calculus. And if factoring is the issue, that's an algebra issue. Go back, study, learn, practice. You got to know how to factor. Got to know how to factor. Now, can I check this? Can I check this? How? If you plug in 1 and 3, what should be the result? 0 for the derivative, not y1, but y2 and y3. So again, you have that calculator, practice it. If I plug in 1, enter, the derivative is 0. 1 e to the negative 6 is basically 0. It's 0.000. It's your calculator being a little weird, but it's basically 0. And you get 0, 0. Are we okay? So again, calculator can totally be used to check. With that, we're done with 2.5, which gave us a really nice introduction to 2.7. Again, there's a bunch of match problems. If you want more practice with derivatives, there's a bunch of practice in there that you can do. That's kind of why I switched over to the notes versus the PowerPoint, is it does give you some extra practice. Okay. Now, 2.7, we're not doing 2.6. 2.7 is marginal analysis. Bottom line, it's the word problems. This whole section is word problems. And what do I mean? Well, we've spent time on cost. The derivative of cost is called marginal cost. Notice it has that little prime, little apostrophe. We've done revenue. The derivative of revenue is marginal revenue. We've done profit. The derivative of profit is marginal profit. So now we're taking the derivative of these things we've been doing, because I don't just want total cost. I want to know how the cost is changing. We're not just going to do revenue. I want to know how the revenue is changing. We're not just going to do profit. I want to know how the profit is changing. Okay. And when we talk about this, is this important? Absolutely. We've used the example of Disney World all the time. Disney World does not make the same amount of money on December that it does in January. In December, it makes a ton more money because of what? Christmas. And then what happens in January? Everyone's broke, right? All the money is gone. So do they keep the same number of employees? Absolutely not. And if they did, they'd lose tons of money. So we talked about seasonal employees. We talked about different strategies, because when there's a lot of people, a lot of money is coming in. When the people are gone, a lot of money is not coming in. So we have to adjust. And usually people are the biggest expense. Okay. So what we're going to focus on today is the difference between marginal cost, which is how your cost is changing, which is derivative, marginal derivative, and exact cost. Okay. I can do the same thing for marginal revenue, exact revenue, marginal profit, exact profit, but cost is the one that makes the most sense. So we're going to do an example. First one, you already know how to do. The second one, I'm going to show you how to do. So again, every word problem, we need to read it, label your input, label your output. So I'm not going to read it at all. I want you to read it, label your input, label your output, label your input, label your output. Read it on your own. Make sure it makes sense first. So this one says a company manufactures fuel tanks for cars. The total weekly cost in dollars for producing X tanks is given by C of X 10,000 plus 90X minus 0.05X squared. What is the input? What is the X? Number of fuel tanks. We are producing fuel tanks. What is the output? Cost. Technically, total cost. Okay. Now, I'm going to give you the whole thing. I want you to do it, check it in the calculator, everything. So basically, you have your cost, and we're going to do it in the calculator. So I'm not going to show as much work as last time. That was really a good setup problem. I want to find out what happens at 500 tanks per week. So I want the cost of 500 in a sentence. I want you to find the derivative of cost, which is called what? Marginal cost. And then I want you to plug in 500, write it in a sentence, and check it in the calculator. And check it in the calculator. And check it in the calculator. Basically everything we did last time, but now we're doing cost instead of an object moving. So now that we've been working on it, I'm just going to do it all in the calculator and discuss it. So I'm going to go to my calculator. I'm going to go to y equals. I'm going to get rid of y1. I'm going to get rid of y2, but I'm going to leave that y3 there. We can use it as a nice check, right? So in y1, I'm putting the original, which is 10,000 plus 90x minus 0.05x squared. Make sure I typed it in correctly. One number's off, one thing's off, it throws everything off. And I want to plug in 500. So I go to the table feature, second graph for the table, and we're going to plug in 500. I'm only worried about the y1 now, not the y3. Okay, we get 42,500. 42,500. Now, please notice the way I'm writing it is to basically explain what's happening right now. So I'm going to try to type it so it's a little bit maybe easier to read. So I'm going to put at how many? 500 what? At 500 fuel tanks, the total cost is $42,500. Okay, so I now figured out my total cost for 500 fuel tanks. Fantastic. That's important. I need to know how much 500 fuel tanks cost. It will cost me $42,500. Okay. Marginal cost is something totally different. It's how that cost is changing. So if you take the derivative of 10,000, what's that? 0. What's the derivative of 90x? 90. And then what's the derivative of minus 0.05x squared? Minus 0.1x. So if you take the derivative wrong, it's going to come out wrong, but hopefully you catch that in the calculator. Okay. So now I'm going to go to the calculator, go to y equals, and in y2, put 90 minus 0.1x. Now, if I did this correct, what should match? Y2 and Y3, Y2 and Y3. So when I go to the table, Y2 and Y3 both give me 40, which is great. So I got the answer, but the question is, can I explain it? That's the hard part, right? So remember what we're doing is we're stopping at 40. So at 40 fuel tanks, what's happening? The cost is, it's positive. Do you think it's going up or down? If it's positive, increasing 40 what? $40 per fuel tank. Remember, last time, it was feet per second. Output over input, slope, feet per second, y over x. This time, it's cost per fuel tank. So what this means, I am stopping production. We've made 500 fuel tanks. Stop. The next fuel tank that comes off the machine is going to cost me what? $40. So it's the cost of the next one. Because of that, another way to write this is the cost of the 501st fuel tank is $40. Both of those statements are correct. At 500, thank you. I know you guys are trying to catch me. At 500 fuel tanks, the cost is increasing $40 per fuel tank. That means the reason why I prefer that statement is it reminds you that it goes up or goes down, and it's changing. Cost per fuel tank. So my preference is you write it this way. We've stopped at 500. How is it changing at that moment? $40 per fuel tank. But I would be remiss if I didn't say it is exactly the same as saying the 501st. The 501st fuel tank is $40. It's the same thing. Now, I know some people are like, wait a minute, do we plug in 500 or do we plug 501? The answer is you plug in 500, because when you plug in 500, it always tells you the next. You've stopped at 500. We've already produced 500. This is the next one. Okay? Now I'm pausing there because the problem I'm going to leave you to do after I do one more thing is going to say and first, and you're going to know which one to do. Okay? But before we do that, all of this is marginal cost. The next thing, which is a very quick topic, is called exact cost. So if I want to find the exact cost of the 501st, there is no derivative. There is no calculus at all. That is the cost of the 501st minus the cost of the 500. And you're like, wait a minute, what does that mean? That means when I ask for exact cost of the 501st, all I want is the cost of 501. I want the cost of 500. Now, just watch, don't do it. Just watch, don't do it. I'm going to show you a little trick to your calculator. Don't do it, just watch. If you go to y equals, and I don't want to do derivative anymore, don't do it, just watch. If I go to these and I push enter on top of the equals, it will no longer show me the derivatives. It will just show me the highlighted equals. The reason why is when you want exact cost, I'm going to go to the table. I want to know the total cost of 501. I want to know the total cost of 500. The total cost of 501 is technically $42,539.95. $42,539.95. And the cost of 500 is $42,500. $42,500. Now, thinking wise, okay, this is how much 501 cost. This is how much 500 cost. If you subtract them, you're left with what? Just the 501st. Now, you're going to tell me, hey, the exact cost for 501 is $39.95. What was the marginal cost? 40. Should they be the same or very close? Yeah, because they're saying the same thing. It's two ways to find the same thing. One is with calculus, one is just plugging in the numbers. Now, I'm going to ask you for both. Marginal cost means do the derivative and find it that way. Exact cost is 501st minus 500. 501st minus 500. So I'm going to leave you one of these to do. I'm going to leave you one of these to do. I'm not going to do it for you. I'm not going to do it for you. I'm just going to leave it for you. You are going to do this one that deals with bicycles. I'm not even going to read it. But I am going to tell you, when you do this one, you're going to find the exact cost and you're going to find the marginal cost. Okay? But the part that confuses people, and that's the only part that I'm going to help you with, is when you find exact cost of 121, what are you going to do? The cost of what? 121 and the cost of 120. And then you figure it out from there. But for marginal cost, if you want the 121st, what am I going to plug into the derivative? 120. Why 120? Because when you plug in 120, it's the cost of the next. The cost of the next. So be careful with that. I'm not going to do it. I'm not even going to read it for you. But that's where we're going to pick up next time. That's where we're going to pick up next time.